Hello students, welcome to our student support program for additional mathematics, grades 10 and 11. Our topic is series and we are going to look at geometric progression. This is the first lesson on geometric progression. So let us start. The objectives of today's lesson are to recognize a geometric progression, to find a specific term in a geometric progression, and to find an expression for Tn in a geometric progression. So let us consider the following sequences. Part A, we have 1, 4, 16, 64, and so on. Part B, 10, 20, 40, 80. Part C, 243, 81, 27, 9. What do you observe in these sequences? We can see that in each of these sequences, any pair of consecutive terms gives the same ratio. If I consider part A, 1, 4, 16, 64. What should I do to get the next term? I should multiply by 4. Or I can say 4 divided by 1 is 4. 16 divided by 4 is 4. 64 divided by 16 is 4. Part B, 10, 20, 40, 80. So what should I do to get the next term? I have to multiply by 2. I can also say 20 divided by 10 is 2, 40 divided by 20 is 2, and 80 divided by 40 is 2. Part C now. 243, 81, 27, 9. I need to multiply by 1/3 to get the next term. Or I can say 81 over 243, which is 1/3. 27 over 81 equal to 1/3. Or 9 over 27, which is 1/3. So we can see here that we are having to multiply by the same value to get the next term. In this case, we say that we have a common ratio. And these sequences are called geometric sequences or geometric progression. So what is a geometric progression? If in any sequence, the ratio between any two consecutive terms is always the same, we then say that the sequence is a geometric sequence. Now let us have a look at the notations which will be used. So just as in the arithmetic progression, here also we will have the first term denoted by A, but we are not going to have common difference as in AP. Here we will have common ratio, which is denoted by R. The number of terms will be n. The nth term will be Tn. Now we are going to have a look at some examples of geometric sequences. So here we can say that the first term is 1 and the common ratio is 4. Remember, we had a look at this earlier and we saw that we need to multiply by 4. So the common ratio is 4. Part B, the first term will be 10 and the common ratio will be 2. Part C, the first term will be 243 and R will be equal to 1/3. Now, how do we find R? We can obtain the value of R, the common ratio, by taking the second term divided by the first term, or the third term divided by the second term, or in general, to get r, we take Tn divided by Tn minus 1. Now, the formula for Tn. So, in general, the first term, T1, will be equal to A. T2 will be A times R. T3, we will take the second term, we will multiply by the common ratio R. That is AR times R, which is AR square. In the same way, T4 will be the third term multiplied by R. That is AR square multiplied by R, which is AR cube. So in general, Tn will be equal to AR to the power of n minus 1, where A will be the first term, R will be the common ratio, and n will be the nth term. Let us have a look at the first example. For each of the following geometric progressions, find the first term A and the common ratio R. So for part A, 2, 6, 18. We can say that the first term here is 2, that is A equal to 2. Now to find the common ratio R, I will take the second term divided by the first term. That is 6 divided by 2, which is 3. Part B now, 64, 32, 16. So here my first term will be 64, that is A equal to 64. To get the value of R, we take the second term divided by the first term, or I can also take the third term divided by the second term. So here R will be 32 over 64, which is half. Part C, negative 4, 16, negative 64. So A will be equal to negative 4. Now R will be 16 divided by negative 4, which is negative 4. We now move on to the second example. Find the seventh term in the geometric progression 2, 8, 32, 128, and so on. Hence, find an expression for the nth term. So here we have 2, 8, 32, 128. What will be our first term? And what will be the value of R? So A will be 2, R will be 4. 8 divided by 2, which is 4. Now, using the formula for Tn, which is equal to A R power n minus 1, I need to find the seventh term, that is T7, which is equal to A R power 6, because n is 7, so 7 minus 1 will give me 6. So now I replace A by 2 and R by 4, which will give me 2 times 4 to the power of 6, and T7 will be equal to 8,192. We also need to find an expression for the nth term. So using the formula Tn equal to A R power n minus 1, I replace A by 2 and R by 4. Now I have simplified the 4 as 2 to the power of 2. So using laws of indices, I simplify the expression for Tn. I will get 2 to the power of 1 plus 2n minus 2. Simplifying, I get the final answer as 2 to the power of 2n minus 1. Let us have a look at the third example. In a GP, the fifth term is 100 and the eighth term is 800. Find the first term and the 15th term. So we have been given the fifth term is 100. I will use my formula for Tn, which is equal to A R power n minus 1. So fifth term is 100, that is T5 equal to 100. I replace in the formula and I get AR power 4 equal to 100. The eighth term is 800, that is T8 equal to 800. Replacing in the formula, I get AR power 7 equal to 800. So we can see here that we have two equations and we need to solve simultaneously. So I label my two equations, 1 and 2 respectively. However, here we are not going to use our usual elimination method, that is adding or subtracting. Here, when we have geometric progressions, the easiest way to solve our two equations would be to cancel the terms. We are going to use division. So equation 2 divided by equation 1, I will have AR power 7 over AR power 4 equal to 800 over 100. We can see here that A will cancel. Using our laws of indices, R power 7 divided by R power 4 will give me R power 3, which is equal to 8. R will be the cube root of 8, which is 2. We now substitute the value of R into equation 1 or 2. Here I have chosen equation 1. So A times 2 to the power of 4 equal to 100. I will get A equal to 100 over 16. Simplifying, I divide by 4, I get 25 over 4. Now I need to find the first term, which is 25 over 4, and the 15th term. So replacing in my formula, T15 will be equal to AR power 14. I get 25 over 4 times 2 to the power of 14. Now 4 is 2 to the power of 2. Using the laws of indices, 2 power 14 divided by 2 power 2, I will get 2 to the power of 12. So T15 will give me 25 times 2 to the power of 12. Moving on to example 4. In a GP whose terms are positive, the fifth term is 9 and the seventh term is 81. Find the 10th term of the GP. So here we are going to use Tn, which is equal to AR power n minus 1. And we have to be careful. All the terms in the GP are positive. So the fifth term is 9, that is T5 equal to 9. AR power 4 equal to 9. The seventh term is 81. So T7 is equal to 81. AR power 6 equal to 81. Labeling our equations 1 and 2 respectively. Now we have to solve both equations simultaneously. So as I mentioned earlier, we are going to use division here to cancel one of the unknowns. So equation 2 divided by equation 1 will give me AR power 6 over AR power 4 equal to 81 over 9. A will cancel. I will get R power 2 equal to 9. So R will be equal to 3 or negative 3. So going back to what I said earlier, here all the terms are positive. If all the terms are positive, this means that I cannot have a negative common ratio. So here we will reject R equal to negative 3. Therefore, R will be equal to 3. Now we substitute the value of R into equation 1. So A times 3 to the power of 4 equal to 9. A will be equal to 9 over 81, which is 1 over 9. And I have been asked to find the 10th term. So T10 will be AR power 9, replacing A by 1 over 9 and R by 3. I get T10 to be equal to 187. Example 5. Find the seventh term of the GP 139 up to 6,561. How many terms are there? So let us have a look at the solution. Here is our formula. So in this GP, the first term is 1. That is A equal to 1. Our common ratio R will be 3 divided by 1, which is 3. So using Tn, we need to find the seventh term. So T7 will be AR power 6. That is 1 times 3 power 6, which is 729. Now we also need to find how many terms we have in this GP. So Tn is AR power n minus 1, and I equate it to 6,561. I replace A by 1 and R by 3. I get 3 to the power of n minus 1 equal to 3 to the power of 8. So 6,561 can be written as 3 power 8. Now I compare and I get n minus 1 equal to 8. Therefore n equal to 9. That is, we have 9 terms in this sequence. So now I will give you some exercises to practice on what we have learned today. The first question, find the first term and common ratio of the following GPs. Question 2, for each of the following GPs, you need to find the indicated term or terms. Number 3, for each of the following GPs, find an expression for the nth term. And then you have a few more word problems on the GP to find the nth term. So students, we have reached the end of the first lesson on geometric progression. In today's lesson, we have learned how to recognize a geometric progression, how to find a specific term in a geometric progression, and how to find an expression for Tn in a geometric progression. So until we meet again, it's goodbye.